Hey everyone, Ray Tayson here. Welcome back. Today we're diving into the universe's most exclusive parties, star clusters. Imagine cosmic gatherings from loose get-togethers to jam-packed raves. And tonight, you're on the guest list. We'll explore how stars are born together, live, and eventually drift apart, and even how our sun was once part of a stellar family. By studying these clusters, we unlock secrets about the life cycle of stars and our place in the cosmos. So, let's fire up our curiosity and blast off into the dazzling world of star clusters. So, what's a star cluster? Simply put, it's a group of stars, sometimes hundreds, sometimes millions, all born from the same giant cloud. Think of it as a cosmic litter of puppies, tumbling through space together. Some clusters are sparse, like diamonds on velvet. Others are so dense, they look like a single fuzzy ball. The shape and size reveal a cluster's age and history. Young clusters drift apart, while ancient ones have held together for billions of years. So when you spot a cluster in the night sky, you're seeing a cosmic family, a snapshot of drama unfolding over eons. That's the magic of star clusters. Astronomers split star clusters into two main types, open clusters and globular clusters. Open clusters are the social butterflies, young, loosely bound, and found in the Milky Way's disk. They're home to hundreds or thousands of hot blue stars, spread out like friends at a park. But these gatherings are temporary. Galactic forces pull them apart over time. Now meet the party buses, globular clusters. Ancient, massive, and incredibly dense, they pack hundreds of thousands of stars into a tight sphere. Globulars orbit the galaxy's halo and have survived for billions of years. Two cosmic parties, two very different vibes. Here's a wild fact. Our sun wasn't always a solo act. Billions of years ago, it was born in a star cluster, surrounded by thousands of stellar siblings. Imagine a young sun in a crowded cosmic neighborhood, the night sky ablaze with nearby stars. Over time, the cluster dispersed, pulled apart by the Milky Way's gravity. The sun, like a rebellious teen, left its family and set out on its own. Now it's a solo traveler in a quiet part of the galaxy. Astronomers are searching for the sun's lost siblings by studying star chemistry and orbits, a cosmic ancestry quest. A few candidates have been found, but the full family tree remains a mystery. So, next time you see the sun, remember its wild youth and the cosmic family it left behind. Somewhere out there, its long-lost siblings are scattered across the Milky Way. Even stars have family stories. The sun's journey is a reminder that everything in the universe has a history. We're all part of a much bigger cosmic story. Where do star clusters come from? The answer, nebulae, vast clouds of gas and dust, the universe's stellar nurseries. Gravity pulls clumps of gas together, igniting bursts of star formation. This isn't a solo act. Hundreds or thousands of stars are born together in a cosmic baby boom. These newborns form star clusters, energetic and bright, blowing away the remnants of their parent nebula. Look at a young open cluster, and you'll often see it still wrapped in the glowing leftovers of its birth cloud. The Pleiades, for example, are surrounded by a beautiful blue haze, nebular dust reflecting starlight. Young clusters shape their environment, sculpting pillars and bubbles in the surrounding nebula. The relationship is cyclical. Nebulae birth clusters, clusters illuminate and eventually disperse their parent clouds. It's the cosmic circle of life. Stars born, shining, and returning their material to space. Every cluster is a snapshot of this ongoing process. The universe is constantly recycling, creating new generations of stars and planets. Star clusters are the rowdy kids, reshaping their nursery before moving on. It's a beautiful, ever-evolving dance. Star clusters aren't just pretty. They were once vital navigation tools. Before GPS, sailors used the stars to find their way across oceans. Clusters like the Pleiades and Beehive were giant signposts in the night sky, easy to spot, even without a telescope. In the age of exploration, determining longitude was a huge challenge. Navigators measured the moon's position against star clusters to pinpoint their location. Clusters made these measurements easier and more reliable than using single stars. Imagine trying to use a sextant on a rocking ship. Having a bright, unmistakable cluster was a lifesaver. These cosmic beacons guided explorers, traders, and adventurers for centuries. Star clusters were more than objects of wonder. They were essential for survival and discovery. Next time your phone's GPS lags, remember, people once crossed oceans using nothing but their eyes in these stellar families. The cosmos has always been our guide. Star clusters are silent partners in humanity's journey. Let's spotlight one of the most famous clusters, the Pleiades, or Seven Sisters, in Taurus. Visible as a tiny misty patch, it's one of the closest and brightest open clusters. Named after seven sisters from Greek mythology, its stars are hot, blue, and only about 100 million years old. Cosmic babies. Most people see 6 stars. The lost seventh has inspired myths worldwide. The Pleiades are still wrapped in a blue reflection nebula, making them a favorite for stargazers and photographers. This cluster has inspired stories from the Bible to the Maori and even the Subaru car logo. It's a cultural icon, a scientific treasure, and a living laboratory for studying young stars. The Pleiades connect us to ancient myths and modern science. Next time you spot that shimmering dipper, remember, you're seeing a story told for thousands of years. The Pleiades are more than stars. They're a bridge between Earth and sky. That's the magic of the Seven Sisters. Now, let's visit the Beehive Cluster in Cancer, also known as Messier 44. Once seen as a misty cloud, binoculars reveal it as a swarm of stars, buzzing like bees around a hive. The Beehive is older and more spread out than the Pleiades, with stars about 600 million years old. It's a mature, diverse community, blue, yellow, and orange stars mingling together. Galileo was amazed to discover it was a mass of stars, not a cloud, changing our view of the cosmos. The Beehive is easy to find sitting between Regulus and Pollux and is visible to the naked eye on dark nights. It's a subtle but rewarding target for new stargazers. While the Pleiades get the spotlight, the Beehive has its own quiet charm and rich history. It's a reminder that even the fainter clusters have stories to tell. The Beehive is a cosmic metropolis, patiently waiting for us to look closer. Every cluster, bright or faint, is a chapter in the universe's story. Meet Omega Centauri, the heavyweight champion of star clusters. Located in Centaurus, it's the largest, brightest globular cluster in the Milky Way, with about 10 million stars packed into a sphere 150 light-years wide. It's so massive, some astronomers think it's the core of a cannibalized dwarf galaxy. Unlike typical clusters, Omega Centauri has stars of different ages and chemistries, hinting at a complex galactic past. If true, we're looking at the heart of a long-dead galaxy, a ghost haunting our own. Omega Centauri is a survivor, a glittering city of stars born from cosmic collisions. Sadly, it's best seen from the southern hemisphere, but if you get the chance, it's unforgettable through a telescope. It's not just a cluster, it's a monument to the universe's wild history. Omega Centauri is the grandest star party in our galaxy. It's a reminder that the cosmos is full of surprises and hidden stories. Every cluster has a tale, but this one is truly epic. The universe's heavyweight champion shining on. That's our whirlwind tour of the universe's greatest star parties. From youthful open clusters to ancient globulars, these stellar families are cosmic storytellers. Which cluster is your favorite? Let me know in the comments. If you enjoyed this journey, hit like, subscribe, and ring the bell for more cosmic adventures. Your support helps us keep exploring the wonders of space together. Until next time, this is Ray Tayson. Keep looking up and don't forget your space guitar.